Hello and welcome to another Jog Vlog session. This session is going to be looking at the UK's climate, and it is one of two lessons where we're focusing now on the climate of the UK. We're going to start by looking at the UK's past climate, and then we're going to move to the present. So, looking specifically at the last 1,000 years of the UK's climate and how a couple of major kind of climatological events have affected the UK in certain ways. So, a bit of background to the UK's climate, which is worthwhile you jotting down for your notes, is firstly where the UK is situated. So the UK is 50 to 60 degrees north of the equator, and that means that we are getting further away and have a higher angle of incidence. So essentially, the equator is 0 degrees. That means it's the place on the Earth most likely to get the most direct sunlight most of the year. The UK being 50 to 60 degrees north of that means that at certain times of the year our solar radiation is more spread out, and in fact in general it's more spread out than the equator. So the same solar radiation is spread over a wider area, meaning we're not going to get the extremes of temperature that you might find closer to the equator. We do, however, have seasons, and we've got a temperate climate. So our temperate climate means it's not consistent year round, and we know that we've got seasons. We have winter, spring, summer, autumn, etc. Now, if I focused on just the two kind of ends of that, if I look at winter and summer, the reason we have these differences in our kind of seasonal temperatures, our variations, which you don't see in the Amazon rainforest because it's on the equator, or you don't see in desert environments because they're closer to the equator in the tropics. What we have is, combined with the fact that we've got a lower angle of incidence, or so a higher angle of incidence from the sun and more spread out, we also have a tilt factor. So the Earth is on a tilt on its axis, and we've kind of encountered that earlier on in this topic. And that tilt means that during sort of June to August to September time, our summer months, we're actually angled more towards the sun, because that happens to be the time of year where the Earth in the northern hemisphere is angled towards the sun because of this tilt. And that's why we have summer. Our summer months essentially coincide with us having a very much more kind of exaggerated tilt towards the solar radiation. So it's more concentrated, and that's why our temperatures go up. And now during that particular time of year, the southern hemisphere is actually tilted away from the sun, so they have a higher angle of incidence than they would normally, and therefore it's their winter. Now, you spin the Earth around the sun by 6 months more, and the opposite is true. We are then angled away from the sun, and the southern hemisphere is angled towards the sun. So, traditional Christmas dinner in Australia is a nice barbecue on the beach, whereas obviously we're inside with our fires on and eating hot food and drinking wine, that sort of thing. So the temperate climate of the UK is seasonal, and that's largely to do with our position completely really to do with our position on the Earth at between 50 and 60 degrees north of the equator. Now, that brings benefits. We don't suffer with extreme weather events. Okay, so we don't get tropical cyclones, and we don't get long-term droughts. Those are things that really tend to happen in climates that are far more prone to either wet and dry or higher temperatures. I'm not saying that our temperatures aren't increasing, but I'm saying that we're not going to get a hurricane anytime soon, because that requires the water around the UK to be very, very much higher than it is currently, and there's absolutely no way it's going to get there. And go into the water in August in the UK will tell you that it's not that warm. So we don't suffer these extreme events, but more extreme flooding and droughts are taking place in the UK. But frontal rainfall is also a very common factor, so we do get a lot of rain, and Britain is associated with having lots of rain. Not so much us in East Anglia, we're a very dry part of the country, but it is associated with lots of rain, and it's frontal rainfall. So warm air from the south coming up from the equator, meeting cooler air from the north, forcing that cooler air up, where if it's forced up, it'll condense, and the water in it will condense and form clouds, which eventually will lead to precipitation. So that explains the UK's climate typically kind of today. Now, that's not always the consistent way, and there are things that change and have changed over the course of the last 1,000 years, which you need to be aware of because they specify in the exam board. Okay, so once you've got these notes, you feel free to move on. So this is a handout, or I think it might be on 365 in the job logs folder, but I'll explain this. This shows you temperature changes in the UK, not just the UK, but globally, but in the UK over the last 1,000 years. And what we've got here, okay, very specifically, you've got a period of warmer temperature, which is known as the medieval warm period. Guess when that happened? Medieval times. And not technically, but close. The Little Ice Age wasn't a full-blown ice age, but it was a period of cooler weather than we were used to. There is a lot of reports of the Thames freezing over, for example, which just is unthinkable now. And then present day, obviously, we've got kind of a bit higher up. Now, if you plot the kind of IPCC report, okay, or the hockey stick graph, we've got the medieval warm period identified here, and then you've got your Little Ice Age identified here. Now, it's not as clear cut on this graph because this is a far more simplified kind of version of the 1990 report when it came to climate change over the last 1,000 years. And this bit here, the hockey stick graph, because it looks a bit like a hockey stick, that's kind of like what's going on now, which we're quite concerned about, we are worried about. This is showing you that global temperature rise, which we need to be a little bit, very worried about. But the two things I want us to focus on is this medieval warm period and the Little Ice Age, and how that has affected the UK's climate on a kind of a practical level. Okay, so in summary, and this really is just a summary, this is not going to take you very long to do, I've got a table that shows you the medieval warm period on the left and the Little Ice Age on the right, and a number of sort of factors that I want you to just jot down, really. So if you want to take a screenshot, feel free. When did it occur in terms of its time period? The impact it might have had, or the effects of that. What were the specific crop-based effects, and why do we think that particular climate pattern happened? Why did the medieval warm period happen? Why did the Little Ice Age happen? So I'll talk you through that, and then essentially this session is done, because that's all there is to say about this particular bit. So the medieval warm period occurred between 950 and 1100 AD. So it happened well before even Mr. Lockley was born. You'd be surprised to know. But there is still documented accounts, etc., written record that help us work out what it was like during that time. So temperatures during that time were high enough, again it's a warm period, to actually grow grapevines as far north as York. Now York is in North Yorkshire, so it's quite far up the landscape of the UK, quite far north of where we are in East Anglia certainly, and not necessarily associated as a wine growing district, but they were able to grow grapevines during that period of time. In terms of other crops, crop yields actually increased because the milder winters meant that there was more potential to grow crops for longer periods of time during the year. Now that's not to say that mild winters are always great, they don't always help people growing crops agriculturally, but this really was before the agricultural revolution anyway, so people's just day-to-day crop yields increased. And that meant that the population increased because well-fed people think, and look, this is not for no time, it's a 150-year period, that's several generations going through, thinking actually, oh great, we can grow loads of food, let's just have loads of babies, we can support them, no worries, all right? And the reason that occurred, they think, is because of an increased amount of solar activity, so solar flares, and a period of low volcanic activity. Okay, so less volcanic activity, meaning that the sun's energy was actually not bounced off the ash clouds and things like that, global dimming we call it, which again we've covered in a previous session about the natural causes of climate change. So that summarises the medieval warm period, and again there's a picture of a grapevine if you didn't know what one looks like, and we are actually seeing a pattern or a trend of that happening now, because even in Norfolk, which I know it's not as far north as York, but in Norfolk they've actually recently in 2017 won the world's best white wine for its category from a vineyard just south of Norwich. And I've tried this stuff. It's Bacchus. It's called BAC. I'm not going to get a free advert. It's the Winbury Wineyard, and it's absolutely delicious wine. Really, really nice. And we won. We beat the French. We beat the Italians. We beat all these other wine-producing regions to produce this amazing variety of white wine. And that's, again, our temperatures are increasing. We are finding that effect, really, of the hockey stick part of that graph. So it's not all bad, climate change, okay? At least we're going to get good wine. Now, the Little Ice Age, that occurred later, so between 1600 and 1850. And the opposite is obviously the case. Temperatures were low enough, the Thames froze, and it was actually thick enough for people to walk on. So people were walking from one side of the Thames to the other. The winters were longer, they lasted a longer time, which meant crops failed. So whereas in the medieval warm period, crop yields were going up, crop failures were much more commonplace during the Little Ice Age, and that led to obviously poverty, starvation, some problems. And they think that was mainly because of a decrease in solar activity, but also one notable extreme volcanic eruption. Mount Tambora erupted in sort of the 1700s. I can't remember the exact date, and might even be in the 1800s, early 1800s. It produced such a large ash cloud that it blocked so much solar radiation that actually parts of Europe crops failed. And Tambora is on the other side of the world, so it just shows you the impact that an ash cloud can have if it gets caught up in atmospheric circulation. So you need to get all this information down, please, for your notes, or screenshot it, and then you are essentially clued up on the two major events and how they affected the United Kingdom over sort of the past 1,000-year period or so. All right, okay, so that finishes that session. Thank you very much for listening, and next session we are going to be looking at the UK's present climate and what affects it and why. Okay, thank you very much for listening, and I'll see you next time.